Hey guys, welcome. Today in this video I would like to show you how you can prepare a smart contract that can trade your NFTs. And somebody asked about this in the comment section, and I think it's really cool idea that we can actually have the separate smart contract that is able to hold information about the pricing, and whenever somebody interacts with that smart contract can trade the NFTs from separate smart contract. So if you don't know how to mint your very own NFT using ERC-1155 smart contract, check out some of my previous videos. You're gonna find also the link to that video somewhere here or there, so you can click and familiarize how to prepare your very own smart contract for NFTs. So I assume that you already have the smart contract and you can use it. So here in the here I have the separate tab where I already have the code of that smart contract, so we're gonna deploy it soon. But now I will prepare the smart contract that would be responsible for holding pricing and information about the tokens that we want to sell. And of course I will also show you how you can allow other smart contracts to call the functions from the other smart contracts. Also, if you would like to join, in the description you can find link to the free Web3 starter email cards from me, so you can just leave the email and you will receive from me 2 emails per week with some curated resources for JavaScript developers that will help you jump into the Web3 ecosystem. So if you are interested in that, just join. Besides this free course, you will also get access to my closed Discord channel on which you can ask questions about the Solidity, exchange knowledge with other developers, or just find some interesting projects to work on together and learn new things. So we have the ERC-1155, and now we're gonna need the new contract. We're gonna call it NFT Trader, and of course we need to also import ERC-1155 implementation because we're gonna need that in our smart contract here. Actually, we can import the Open Zeppelin contracts, or we can just import the game items contract. However, we didn't customize anything special. We just customized the URI, which is actually not needed by NFT Trader. So I will not import the NFT Trader. So I will not import the game items contract. I will just import the ERC-1155. So we have the contract here. We have the body of that contract, and here we're gonna have the struct, and the struct is nice or thing in the Solidity language, which can help you build some structures. So for instance, we have the listing, and this is the structure that can have 2 attributes. One is price and the second one is seller. So I think structs are really useful. You can read the official documentation about the structs. I will not cover that in this video, but we're gonna have the listing on which we're gonna store information about the price. So we want to take, of course, the payment for the NFT, and we need to know who is the seller. So we have the struct, and the next thing that we need is the mapping. And mapping is something that you may know from other programming languages. It's something like hash from Ruby or associative arrays. So basically you have the key and you have the value. And mapping here in this example, the key might be the address. So for instance, the address of the smart contract would be the key, and then the value would be another mapping. So we have the token ID, and then we gonna have the listing with the price. So basically, if I would type here something like let's say listings, and here I would type 0 blah blah blah, this is the address of the smart contract, then I can type the ID, which might be 0, then I would get the listing for the token ID from the smart contract with this address and the token ID as 0, and here I would have the price and seller. So as you can see, it's a really nice structure because we can have the unique listing for the token ID, and then we can have a very easy access to that specific price listing. But you will see this in the moment. So we have the listing, and now we're gonna need the function which would be called add listing, just that we can add the information about the price. And this would be the function which we called add listing. It takes price, it takes contract address, because we want to NFT trader be nice smart contract that can work with multiple contract addresses. And then we have also the token ID, because obviously we need to tell the smart contract what we want to sell and how much we want to get. And this would be the public function. However, we need to add some requirements to this function, because obviously the add listing should work only for the people that actually are owning that token, because it doesn't make any sense to sell the token that we are not owning, because we are not able to trade it. So whenever you want to interact with the other smart contract from your smart contract, you have to import it, and then you can use the name of the smart contract and also the type. So here I have the variable called token, which is the type of this smart contract, and then I can just provide the address of that smart contract. And then we're gonna have the first check, and this check is that caller of that function, which is the message sender, has actually some tokens that he wants to sell. So we have the requirement, and if that statement is true, then everything is fine. However, if that statement is false, then the execution of the smart contract, this function, would be terminated, and we would get the error caller must own given token. So token dot balance of course will check the balance of the token ID on the specific smart contract. So we have ERC 1155 smart contract that is on the given address, and we are calling that smart contract from our smart contract. I know this sounds weird, but it's super cool, because we have this kind of modularity and interoperability of the smart contracts, that we can write smart contracts that are talking to other smart contracts, and this is really powerful because it's all decentralized. So we have the check. Whenever we have more than 0 amount of this token, then everything is fine. However, we also need to check whether the NFT trader smart contract is approved for moving tokens, because of course we want to have everything automated, so the seller can add the listing, can specify the price, and then if the buyer comes, and if the buyer will call the function buy or purchase that we will implement in the minute, then the smart contract that we are implementing, the NFT trader, will take the money, will store information about the transfer, and then this smart contract will move the token in the name of the seller. So we have to be sure that actually this smart contract is approved to move the certain token. And we are checking this, again, calling the function is approved for all from the token, and we are checking that for a message sender, because we want to be sure that person that actually adds the listing is that person approved the other address, which is the address of this smart contract. And whenever you want to get the address of currently deployed smart contract, you have the way in Solidity to write address this, and this would return the current address of this NFT trader, because of course if you deploy that, you have the different address and you don't know it in the moment of when you are actually deploying the smart contract. So you have to have this information. And again, if this would be false, then we have the contract must be approved. So we have these checks, and then finally we can store information about the listing. So as I told you, we have the mapping called listings, and this is the public variable. And here we can actually assign that this contract address address has the token ID, and for that token ID we have the listing, this structure, this struct with the price and the information about the seller, which is the message sender. So great, we have the add listing and this function, and for instance we can maybe deploy that smart contract. So if we have the NFT trader, we can deploy it here. And for instance, if I would like to add the listing from some contract, and of course I would need an NFT contract, so I will deploy it right now. Let me select it here. Of course, I need to compile it first, and once it's compiled, then I can deploy the NFT here. And if I deployed the smart contract here, I have this NFT smart contract ERC1155. I can copy the address of that smart contract, and here I will try to add the listing. So I will type the price, which would be in Wei, so it's 1000 Wei. Here is the contract address and the token ID 0, because as you remember, here we have the Charizard, Ivysaur, Venusaur, and the 0 was the Charizard. And if we click here the transact now, we have the error, like contract must be approved, because as you remember, we have the check here. So we need to approve that contract, so we need to take it address, and then we can have here set approval for all, and we can type the operator, which would be the address of the NFT trader, and here we can just write true, and we can write execute that, and of course, I use this address to actually deploy the game items smart contract, and I'm owning that smart contract because here in the constructor I've sent some 100 Charizards to the message sender. So I'm able to actually approve that smart contract. And now let's try again to add the listing. And now if I added the listing, everything is fine, and I can check the listing here. So I would basically take the contract address, type it here, token ID 0, and if I call it, then you see that we have our struct. So already something works. We have the listings added to the smart contract, so we know that the token ID 0 on the smart contract that we just deployed, the price of it is 1000 Wei. So okay, we have the listing stored on our smart contract. So far so great, but of course we need to add a bit more logic to our smart contract to make it actually working. So now we're gonna also need the special mapping on which we're gonna hold information about the balance, because whenever somebody gets money for the NFT, we want to store that information that, okay, the seller received this amount of Wei, and we're gonna store it on the balances mapping. So then we have the function purchase, and of course if somebody wants to purchase the NFT, he needs to tell specifically the address of the smart contract, the token ID, and the amount, because of course on the ERC1155 you can hold 100 Charizards and somebody can buy them all or just buy one. So of course we want to specify that. Then we're gonna have another thing, which is of course we need to get the current listing for that item. So again, we are using our listings contract address token ID. We're gonna store it in this variable called item. So now we can just be sure that the sent money, because as you can see this function is public payable, so whenever you have the function marked as a payable, you can send some ether to that function, and that ether that you send is under the message value. So we need to be sure that somebody transferred actually the price of the NFT multiplied by amount. So if the one Charizard costs 1000 and somebody wants to buy one Charizard, of course we are just multiplying this by 1. But if somebody wants to buy all Pokemons, then of course the amount can be 100, and then we should check it. So okay, we have this requirement that we are checking that enough money was sent to the smart contract, and once we are sure that enough money was sent, then we are storing information on the balances that this seller, this guy, received the money. So we are incrementing the balance of this guy. Then of course, if we are purchasing, we want to take the money, we want to store information about how much money was sent, and finally at the end of this purchase function, we want to transfer the NFT, because the ERC-1155 smart contract that we are inheriting from has the built-in function called safe transfer from, and then we can just provide information that from the seller to the sender, so the guy who is purchasing, we want to move the token ID. And of course, we are moving this amount, sending no data. So we have this purchase. Of course, you can also, as a homework, add here another requirement that you are checking that this amount of NFTs is actually available. So you need to do the require balance of. I don't want to waste time on that, but you would have the homework just to change the implementation of that smart contract, because if you want to learn something, you cannot just watch these videos. It's not enough, trust me. You can only learn this by doing, by having silly mistakes that you have to solve it on your own. So trust me, you have to actually try this code, not only watching. It's not enough. So we have the function called purchase, and now I think it's perfect time to actually also provide the function that will allow us to withdraw the funds, because obviously if you are the seller and somebody sends the money and the NFT is moved to some buyer, then the seller of course wants to withdraw the Ether. And of course, as you can just right now pause the video and try to implement that function yourself, or you can just see how this works. So first of all, we're gonna check that, okay, if I want to withdraw the money, I need to specify how much money I want to withdraw, and then I can specify where I want to send the money. Of course, you might ask that, okay, withdraw should always transfer money to the sender, but I think making the function withdraw that you can specify the destination address, it's a bit more flexible. It can also help you save some gas transaction, because then you would always get money to your account and then you have to maybe transfer it somewhere else. And now if you have the withdraw function in which you can just specify the destination address, you can save some money on the gas transactions. So we have the first check whether the amount that somebody wants to withdraw is less or equal the actually balance of the guy that wants to withdraw. So we have the message sender, and then of course if somebody wants to withdraw more, then we have the insufficient funds. And once we check that everything is fine, then we have the dest address, which is address payable, and inside this variable we hold the information about the address to which we want to send the money. And whenever we have the address which is the payable, we have the function called transfer, so the smart contract will transfer the Ether. And here you just provide the transfer, the Ether in way. So for instance, it would be 1000, and this 1000 will go to this destination address. And then of course, once everything is successful, we also need to store information that we have less balance for this guy, right? Because he already withdrew the money, and we also need to track this. Yeah, we don't gonna need this. So now I think it's a perfect time to actually deploy the NFT trader smart contract again. I will keep maybe the game items, so I will keep that smart contract, and here I will use JavaScript virtual machine, so I have here some wallets. So don't be surprised that I'm not using MetaMask, because I'm just testing and showing you right right now how to use the remix and how to write the code. Of course, if you are on production, you can use Hard Hat, you can use Truffle, or you can use any other JavaScript tool to write the smart contracts. But I'm just to keeping things simple. I will just show you how this works in the browser. So we have the JavaScript VM, and right now that was the guy who minted this smart contract. I will deploy right now the NFT trader, and again we have to add the listing. So I will add the listing about the Charizard. Charizard is here on the ERC 1155 smart contract, and here I can specify the price for this guy, and of course I want to sell the Charizard, so it's gonna be the token listing. And again we have contract must be approved, so because obviously it's a new contract, so we're gonna approve it again. That's the different address. We're gonna send the transaction, and then let's add the listing again. So we have the listing, and right now I will try to purchase the token 0 for this amount of money. And of course it doesn't make sense to buy the token from me, right? I'm the seller and I cannot be buyers, right? So I will just change the address right now. So right now I'm no longer the seller. I'm just using the different address. So I'm new guy, right? I'm the buyer. So I have the account here, and let's try to purchase this specific token. So of course I have to specify the contract address, because this is the special Pokemon NFT, right? Then I want to buy the token ID 0, and then I want to buy one amount of it. And then inside here, if I would just call it like that, then of course it doesn't work. It's reverted because the insufficient funds sent, right? Because I didn't send enough money to this function. Of course, if I would specify here the value of Whey, right? So I want to spend this amount of Whey, and you see that I have 999.999. So if I will click the purchase right now with the token 0 amount 1, now you see that actually I purchased the token. And of course we need to update that. Here we can see that some amount of money was changed, and then let's see the balance. So let's see the balance of actually this guy that minted the token. So I will send it here, and you can see that we have the balance that we can actually withdraw. And I will withdraw this money not to my account, but I will withdraw it to completely different account. So I will just type here. So I will just type here this money that I want to withdraw it, and I will withdraw it to, for instance, this address. Of course, I need to go back, and I can specify it here. And if I click, and let's try to call maybe the withdraw from different accounts. So from the buyer, let's try to be a hacker, right? So I will try to withdraw the money that actually I don't own. And here you have the insufficient funds, because obviously I don't have this money in the smart contract and I cannot take it. But if I'm the guy who was the seller, then I can try to withdraw, and then I just click this. And of course, if I will do it again, then I have the insufficient funds because I'm not able to withdraw any more money. And now you can see that this address has more Ether than it had before. Before it had 100 Ether. Now right now it holds 100 Ether something, because obviously the way it's damn small. So if you want to transfer 1 Ether or more, of course you have to put more zeros. You can read on that in the internet. So of course, we did the purchase, we did the withdraw, but right now, let's be sure that actually these changes are reflected on this NFT smart contract. So first of all, we're gonna take the address of the original minter of this token, and originally he holded 100 tokens. So let's see how much this guy has now, and we see that he has 99 copies. And if we take the address of the buyer and submit it here, Now you see that the guy has one copy. So you know that how you can create the contract that can call the functions from different smart contract, and this way you can learn that it's super great to actually connect smart contracts with each other, because then you can build some nice stuff on top of other smart contracts. I hope you learned something. If you like the video, smash the like button. You can also use the comment section down below to ask me some questions, or just give me some ideas to actually work on other videos from Web3. So thanks you for your attention, and see you on this channel.